Nathan Libby with Best Buy Metals. We're going to talk about our mechanical seam lineup, and we're going to go through some of the processes of installing the trim, the panels, seaming the panel, and then a couple of the trim that go on top. Before we talk about that, we're going to talk about the three types of mechanical seam we offer. We offer a mechanical seam 100, which is 1 inch high. We offer a mechanical seam 150, which is 1.5 inch high. And then last but not least, we also offer a mechanical seam 200, which is 2 inches high. So those are the three systems we offer. The 1 inch and the 1.5 inches both require the same set of hand seamers and drill powered seamers. Very similar, except for the rib is taller. The 2 inch requires a different set of hand seamers and a different drill powered seamer, and we'll have slightly different setup, but very similar other than that rib height and the need for different seaming tools. Each of these systems has their own clips. Each one is available in a fixed clip or a floating clip. There are different options on floating clips depending on the type of project you're working with. What we're going to focus on today is the 1.5 inch, so the mechanical seam 150, and we're going to talk about that predominantly. So just know that if you're going over solid decking, the overall process will be very similar for all three, although the 2 inch does require a different seaming tools. So let's get into it. So before we start, I'm going to talk about some of the tools. A few tools I want to talk about are cutting tools. So we have left cutting, straight cut, and right hand snips. Left hand, straight, and right hand snips. So just depending on which way you're starting, which side of the piece you want to be a little more refined, you can use any of these tools. You can also use a right cutting, this is left actually. You can use left cutting upside down and create a similar result, depending on the situation. So another cutting tool that's very helpful is our Malco panel cutter. So this is a rotary tool, and it works great for the flats. You cannot use it to go up and over the ribs. So a lot of times what you're going to do, you're going to use it for going your long straight cuts. Works beautifully, attaches to just any cordless drill, and it will adjust to meet that drill size. But also you can use it for flats going across the panel. You just have to cut off the ribs first. Or you have to cut one rib, go across, and then finish it with snips from the other side. A few more tools we're going to talk about is hemming tool. So we're going to be hemming the panel at the eave. That's very common on solid substrate installations. Sometimes you can avoid that by using a set of screws at the eave without hemming the panel, especially on commercial projects and things like that. These are hand seaming tools, and they work for a number of purposes. One, they can help you close up the hem after you made that hem, often with a piece of cardboard there just to help prevent rubbing. You can also use it just to make folds for your trims at the end. So if you want to make a nice fold down for your gable trim or for the ends of your ridge cap, or even just to straighten up a panel. If it has a little bend on it, you can use it to help straighten up a panel. A few other tools we're going to talk about. First, we have a hole punch. So we have this set at 1/8 inch. It also comes with a larger size punch in the box, but we're going to use the 1/8 inch for our 1/8 inch pop rivets. It'll punch right through 2 or 3 layers of metal, especially 2. Rivet gun with the 1/8 inch bit is inserted, so the same purpose. That's the tools we're going to talk about. Measuring tape, just some scribing. We've got some pancake screws. We've got some pop rivets, and then some double bead butyl tape. We also have our we also have our clips. These are 1.5 inch floating clips. It would work the same way if you're using a fixed clip. It's just going to be about the same height as the rib. and it's going to lock over that first panel. You're going to screw that down, lap the next panel over, and then seam it. So that is that's a floating clip, so it allows it to slide for if you have really long panels, especially like panels over 40, 45 feet. These have become very important to have those to be floating versus a fixed clip. So we're going to go ahead and this is the hand seamer for panels, hand panel seamer for mechanical seam. Technically, you can make the entire panel, you can seam the entire panel with this tool. Today, we'll mostly be using it to end the panel where the Joule-powered seamer does not get close enough to the edge. In some situations, you can use this to make either a 90 degree, where it just seams flat over once, or you can flip it the other way and make it, and after you make the 90, you can go ahead and turn that all the way down to make a 180 degree seam. And then last but not least, this is the Malco FS-XS. This is designed to work with both the 1-inch mechanical seam 100 and also the 1.5-inch mechanical seam 150. So what you'll notice is it has adjustments for the height of the wheels on all four sides. So right now it's set at the low position for the 1.5-inch profile, all the way around. If we were to loosen that up with the hex, drop those wheels like this, drop the tool down, now it's ready for the 1-inch. So 1-inch or 1.5-inch, right now we have that set for the 1.5-inch height. A couple more things that are important about this tool. You've got your seaming pressure. So right now, the first three dies will make that 90 degree bend. So it's a starting, it goes a little farther, and then it makes the final 90 degree right there. So your start position is here, and your tool is going to run through all three sets of dies. So your panel is going to start right here, generally the location of the end of your panel. The next two dies make the 180, so you can actually turn these off by loosening the seaming pressure, and then instead of doing a 180, you're just doing the first three dies, which is a 90 degree. So right now we have this is opened up, and we have the front three dies about a 1/16 of an inch wider than the four notches. We have the back set about 3 notches in, so you can see there are specific locations that can vary depending on the thickness of your material, but we found this to work good. There you also have your material thickness adjustment. So if it's set like this, it's set for 025 to 031 thick material. And what we want is 016 to 025, which would be from 26 to 24 gauge. So what I'm going to do is pull that up, rotate it, and when it snaps down into position, we know that we're now in the position for the 016 to 025 material. We can also see the starting line right there on the side, so that's very important. That's the edge of your material. There may be times you have to work from the top down and you can't get your tool to that position without pre-seaming. And in that situation, we'll talk about that later, but you seam from here to here, you seam 2 manually, and then right at that start position, we're going to seam from there back to all the way to the 180. So we'll talk about that a little bit. The tool, a few other features of the tool. One of the cool things is this remote control. So it's a very simple mechanism, but it's very effective. So it has a guide for a cordless drill. It's locked on with this bungee, and then this goes around the trigger, and just loosely there you tighten that hex bit, and then that allows you to use the remote to power the drive rollers. So what you'll notice is when I push that trigger, the drive rollers move forward. And the few more things about the tool, you can store that right on the tool. You could actually use that to as well, or you can continue to use the drill button, just depending on what you prefer. The bottom of the tool, these are the drive rollers, and these are the forming rollers. So drive rollers are heavy gauge polyethylene, probably. I don't know what the term for them is. And then the forming rollers is what is going to seam the panel itself. So that is important. What that means is we want to make sure the forming rollers are on the side of the lap where all of the hemming is taking place. So in this case, we're going to be working from the eave up the panel, and our seam that's being folded over is going to be on this side, on the forming side of those rollers. So right now this is also in the open position. So what you'll notice is when I would get this into position, you can't see it from that side, but there's a starting mark right here. So I would have that right at the edge of my panel, and then place the tool on the panel. When I get it right to where I want, I'm going to go ahead and lock that down onto the panel. This is going to be right at the edge of my panel. And then at that point, I'm going to work it forward all the way up to the top, stopping, making sure it doesn't bump and try pulling up at the top. So that's just some basics for this tool. Very well designed, as all Malco tools are. So this is the Drill Assisted Power Seamer, FSXS. There's also an FSXS2, I believe, or 2XS, which is for the 2-inch profile. This tool works for the inch and inch-and-a-half profiles, as does the manual seamers. There's a different set of hand seamers and a different power assist tool for the 2-inch high profile. So for now, I'm going to just move this out of the way, and we're going to work through some trim details. This is an extended eave profile, so has a lip to lock the panel on. We can form this to the pitch of your roof, so which is very convenient. So what I'm going to do first is I'm going to make me some marks. I'm going to leave a tab. Leave about a 1-inch tab at the rake. And I'm just going to use my straight snips to make those cuts. So you can take your hand seamers, or you could probably even just fold that by hand, but make a nice 90-degree bend. So most of the fasteners we're going to be using for the trim and the panels are going to be a pancake screw, usually 1 inch, square bit, number 2. So we're going to take a few of those, and usually we put these about 1 foot apart. And I like to stagger them. So I like to stagger them up and down just a little bit. And there's no need to go too close to that edge. So about 1 foot apart, and that's your extendee. This will be covered over, but just gives a nice tab around the corner. So, okay, so we're going to talk about the panels next. So you can install this panel from left to right or right to left. There's a benefit if you're going from left to right, and that is you can work your drill up the roof. So keep that in mind. These can be installed either way, but if you can work from the eave up, that ensures that we don't have to hand seam the starting position. You will need to finish it off with a hand seamer, but you don't have to start off with a hand seamer if you're working from the eave up. If you're working from the ridge down, if it's a ridge, it's the same thing. There's no concern. Your power tool can ride above the panel, and you can work down without having to start off with a seamer. On the other hand, if you're starting at the top and you're going to be starting at a transition or at an end wall, it's easier to start off at the eave because the back end of that tool has to be pre-seamed if you're going to start at the top and you're not starting with a wide open space for the seamer to begin. The seamer has to have somewhere to begin. It's easier if the panel is just hanging off, or if the panel has at least a benefit of having some space above it. So in this case, we've chosen the easy path just for you, and we'll talk about that momentarily. So here's the panel. This is the 1.5" profile. This is a 16-inch coverage. So I'm going to start this panel off about 1.5 inches past the bottom. And at the top, you have a little bit more flexibility because you're going to have a trim cover that later. So in this scenario, I don't have an end wall trim for the top edge, but in general, you would have a trim that's covering anywhere from 5 to 12 inches, at least a few inches at the top. So if your panel's set back a little at the top, that's okay. It's not going to cause any issues. So this is where we're going to start the panel. I'm going to measure 1.5 inches for an 1.5 inch cut. So we're going to hem these panels. So I'm going to make a mark here. We're going to cut off the ribs.
So marks are made.
Okay. So the clips are removed. I'm going to straighten up that hem just a little bit. So the seamer's coming convenient for that. We'll take our hemming tool, put it over the edge of the panel, and usually works better just put on one side and work it down to the other side. I'm going to hem that around. So there's the hem. We'll go ahead and prepare the next panel as well. So the same thing. We'll set an 1.5 inch mark. Cut off the rib. And we'll hem that panel as well. So again, some of this can be done on the ground. You don't necessarily have to do all your hemming on the roof, and that's convenient as well. So we're going to start off with our first panel. This will be locking onto the eave trim. And for the sake of this panel, I'm going to tack it right at the top. Just to reflect the fact that I'm going to later add a trim that'll hold it in place while we work through the rest of what we're working through. So there again, this is not going to affect the integrity of the roof at all because this will be covered up later by a Z-closure and a trim. So that'll secure that panel in place. Just for the time being, and I'll put one more at the other side of that panel, or maybe more in the middle for this case. All right, so we're going to take our clips. So usually depends on the project. These clips can be put anywhere from 2 foot to 5 foot apart. The most common spacing is right at 3 feet. So this is going to depend on the type of clip, wind resistance, and also what you're fastening over. So for example, the 2-inch seam panel, it's designed to go on open framing 5 foot apart. So especially like a metal building, that type of thing, you have to have the right clip, but it can go quite far apart. So just keep that in mind for this scenario. Is it's going to depend on the product, the project, and the wind resistance. So those screws just snug the panel. And one thing you'll note is I made sure the slide is in the middle of the base. That just ensures it can move up and down as needed as the panel expands and contracts. So metal doesn't expand and contract near as bad as something like vinyl. Vinyl expands much more, and therefore it has to go in more. But the metal still will expand and contract, and especially over when you get to a panel length of about 40 foot, 45 feet. The amount of expansion contraction has a much greater impact on the movement of that panel, and that's where a clip will allow it to move considerable amount, over that distance. So just keep that in mind. And your sales rep can also assist you with ensuring that you get the right clips and fasteners for your project. These are a pancake head wood screw. So depending on the project, you may need a self driller, metal to metal, but these are designed to go through metal into wood, or in this case, just secure clips into wood. So 2 clips in this scenario, but again, we're going to put those about every 3 foot average distance. Sometimes you could go anywhere from 2 to 5 foot, depending on what you're trying to accomplish. So overlap panel. This is not like, this is a lot different than our snap together systems. One of the things that's important to note is our snap together systems don't require the seamer. They're designed to lock tightly together, either after having put a clip down, similar to this, or in the case of something like Tight-Lock 100 or Tight-Lock 150, you don't even need a clip. It has a side flange you fasten through, and then they just snap together. But in this situation, especially one of the benefits of a mechanical seam system, the inch and a half are very historical. So this is the same type of standing seam design that has been installed for hundreds of years, over 200 years. It was just made by hand, and then it was all seamed by hand. And then when you got to the top, you took a hammer and just smashed all the top together. Very interesting. If you go up to Virginia, you'll see a lot of it, usually in flat pan. Some differences here. We don't have to hand seam all of it. We don't have to hand make all of it. And we have modern trims to help cover the edges and that kind of thing. But if you want the similar look, that's the inch or inch and a half give you that historical look. Comparably, the 2-inch is very unique. That 2-inch high rib will span those 5-foot distances for heavy commercial projects. It will also work on slopes as low as 1/2 on 12. So 1/2 inch rise every 12 inches across, which is incredible. Most of our systems, other standing seams, for example, will work on a 3, maybe a 212 slope, like the 1.5 inch will go down to a 212. For the mechanical seam 200, snap seam does down to a 112. So the real tall 1 3/4 ribs will go down to a 112. But because of the way it's going to lock together in the height of that 2-inch rib, it can handle those very low slope 1/2-12 pitches. Very excited about that. So I'm going to go ahead and secure this panel in place with a couple of pancake screws. Like I said, in a normal situation, this would be, I'm actually just going to tap one here up the top, just to hold that in place. And those would all be covered by our trim later on. So they're pancakes, but just as with all of our standing seam roofing, we want to try to hide all of the screws. So later on, your panel would cover that screw, etc. So we're going to go ahead and go into the seaming portion. And because we're going to start from the eave, we won't need to pre-seam anything. We talked about the remote. So that allows you to work from the ground. From from further away, not the ground, unfortunately, but from it allows you to work through Got to open it up. That would be my problem. So it allows you to control it without having to have your hand on the trigger at all times. So I'm looking right here, and I have my start position noted. It's at the edge of the panel. And as I look inside, I can also see the same thing. And so what I'm going to do is go ahead and clamp down on the rib. So I've made sure my start is right at the edge of the panel. I've engaged the seamer, the set of dies, so they've clamped together. And then I'm going to work it up the panel. So I'm just going to stop it right when it gets to the top. So what this has done is it's created a full 180 seam. You can see it's seamed at 90, and then the back set of rollers went ahead and seamed at 180. And then I'm going to go ahead and release the dies. And what you'll notice is at the top, we still need to finish off the last portion where the back dies did not get to. So what I'm going to do is I'm going to go ahead and take my hand seamers, and we're going to start off by making sure it's all bent at the 90 nicely, especially at the very top. Make sure it all got to the 90, and then flip it back around. I'm just really going to dig it in here. And finish off the full 180. So that is as tight of a locked panel as you will get. There is nowhere for water to get between those seams. It would have to raise up 2 inches and then work its way through 2 layers of seams. So this is why this product is it's wind resistant. It's highly weather resistant, even down to low slopes, especially on the 2-inch high. So that is the panel. We're going to go over the Z closure and the gable rake. So a couple of things we're going to talk about. So the Z closure is used in 2 ways. It's used on the side of the panel, at the rake in the sidewall. So that's where I'm going to use it here. And then it's used at the top of the panel to close off the panels, and there it's cut to fit. So we're going to take that and we're going to cut it. With the 16-inch panel, it's very, very narrow, so it might end up being 15 3/4, 15 7/8, somewhere between there to fill the gap between there. And it's going to seal the side of the panel for rake and for sidewall. It'll seal the top of the panel everywhere. So ridge, high side, end wall, transition, wherever the top of the panel stops. But for now, we're talking about this. So I'm going to go ahead and measure out the distance. So this is my Z closure. It fits in the open hem of this rake. This is a box rake. We can also provide a Denver rake if you prefer. But it's going to go just like this. So what I'm going to do, have it all locked. And I can actually see it goes right at that bend. It goes right at the inner bend here. So I'm just going to place it right there. In some cases, I would pop lines, measure, and place it, but I can very clearly see it starts right there. So I'm going to place it right on that line. Before I do that, I'm going to apply double bead butyl tape. This stuff is incredible. It acts as a gasket between the Z closure and the panel. It's kind of like caulk on a roll, but it does not dry out. I know that from personal experience, it just does not dry out. So I'm going to go ahead and cut this to length. I'm going to pre-apply the butyl tape. This has a wax paper that gets removed later. And this is a double bead butyl tape. So basically, compared to a single bead, it's just wider. It supports the Z closure better compared to the single bead that we would more often provide for like a through fasten panel for the trim for those panels. So the nice thing is you can do all of your prep on the ground. You can do all of that prep on the ground. Go ahead and put your butyl tape on there, and then when you get on the roof, as long as you know exactly where it's going to go, you can go ahead and peel off that paper and stick that in place. That's the key, as long as you know where it goes, because once it's down, it's hard to get up and it's messy, and you don't want to do that. Another pro tip, butyl tape does get tacky and sticky after a minute, so you'll want to keep it where it's not super cool. Believe it or not, we have people that like keeping it in their coolers. So because of the tackiness of that butyl tape, it just stays in place. I don't really have to hold it in place before I put my pancakes in it, but I do need to put some pancake screws to hold that Z closure down. So about every foot apart generally is what we're going to stick with. Okay, so as you can see, that's the same height as the rib. It's the 1.5 inches to match the mechanical seam 150. So the height of that is just perfect to raise up the rake trim. It's also just perfect to seal at the top of the panel. So depending on what you're using it for, it'll do either. So it's that easy. No, we're not done yet, just kidding. So a couple things. We can either use an 1/8 inch drill bit and drill those in. About 2 foot apart is fine. Or we can also use our Malco hole punch with the 1/8 inch bit. And we're going through 3 layers if I go through right at the hem. Or I can set the depth a little further and just go through the Z closure and through the flat part of the rake trim. In this case, I'm going to go through all 3, so it's going to be a good punch. It's trying to stick to it because I'm going through 3 layers of metal right there. So again, we're going to put those about every 2 foot apart. And as you can see, it went through that. Really found any problem. I just really tried to stick into it because I got 3 layers of metal. Looks like my guide was not tightened up good, so I'm going to go ahead and tighten that up. So the good thing about this is you can set the depth anywhere from, so that is, I'm trying to find the right mark for it, anywhere from 1 inch down to, in this case, down to about 1/4 inch is where it stops. But I'm going to set this up right at 3/8 inch. And you can work with that and determine whether you want to go through all 3 layers or just 2, and either one is sufficient. Make sure you get any loose metal off. Loose metal will leave a little spot there that has the potential to sit down there and just leave a rest spot. Doesn't look great. All right, so I'm going to go ahead and rivet these. Most likely I should have riveted them as I went. That would have made a lot more sense. But hindsight is 20/20. So we're going to go ahead and hit the first one. So we're going to put our rivet in the hole. In this scenario, we're talking about Galvalume. So it's just a stainless steel rivet. Usually we're going to provide that in a color matched stainless steel rivet. So it just works. You're going to put the tool over the rivet, or you can pre-apply it into the tool. And a couple of squeezes, and I'll pop right off. I'm going to do that for the remainder of those.
This last one is an example where I should have went ahead and popped them as I went, because the more offset they are, really, it would have been better just to run ahead and rivet those as I went, instead of trying to get the tool to work with me. Work with the tool.
And then last but not least, into the gable end, there's a few ways we could finish that off. On the side, we could use an offset cleat for a straight rake and lock it on, or we could also use just a couple of wood screws in the side to hold that in place. For a turnover, you can do this beforehand, but I'm going to go ahead and mark 1.5 inches past the edge. So again, if you're on the roof, it might be nice to go ahead and have these, go ahead and do these ahead of time, just so you don't have to fool with it on the roof. It's a professional straight edge right there. And there are a few ways to finish this off. So just keep that in mind as we go through this. There are way more than one way to skin a cat. And a lot of times you can just bend those in by hand. That's really a preference thing at that point. And I think for that the last couple bends, you can either put a screw in that, you can drill an 1/8 inch bit and put a rib in that. Just depending, that's going to depend on the preference of the installer. And so there are a few ways to handle that right around that corner. So that's for a gable rake. The sidewall is very similar, just instead of going down a wall. And the hems on this is the opposite side, so I can't really show it. It's going to go up a wall. So ignoring the hem, that's the difference between sidewall and end wall. Is you're still going to use Z-closure, the full length up the trim, or up the panel, and then it's going to go up a wall instead of down. So that's the difference. We're going to go ahead and go over the top portion. I have this piece left over, and it is awful close to working, but a little long. So we're going to measure for that. So we've got, in between here, I've got 11 and 16 17ths. Sorry, 13. I'm so bad at math. 14 1/4-ish. So 14 1/4 inches. And I'm going to cut this a hair short just because I want to give it a little wiggle room. We're also going to finish that off with, butyl on the bottom and tube sealant on the sides. So you can allow for a little room. So it's going to go between those two, and really I can either cut off the inch that's going to go under here, or I can snip it, give it a little relief. So in this case, I'm going to go ahead and just cut off just the top portion of the Z-closure, just to give it a little relief right there. In this scenario, the location of this is going to depend on our wall flashing. So if you think about what we're going to use, it's going to be very similar to any of our other open hems. It's just bent at the opposite way. So if I were to take this and bend it this way and go down the wall and over and then lock it on. That's what we're looking at. I don't have that trim made right now. So just know that the placement of this would depend on how wide that flashing is going to go out to. And I want to make sure it's locked on to the open hem. So, but in this scenario, let's suppose for now, just for the fun of it, we're working with a 6-inch trim. So we're going to go ahead and work from the wall on each side. I'm just going to make sure we hit 6 inches. So I can do this a couple ways. I can go from the outside and then remove an inch for the inside, or I can go from the inside. It doesn't really make any difference. In this case, I'm gonna just measure that outside, the 6 inches here, and make a mark right where I want the back side of my beetle tape to be here, and then on the other side, just make sure I've kept it square. So once you get that mark, you can pop it and take care of your beetle all the way down or your Z closure all the way down the roof. So I can snap a line here and pop a line on top of the ribs here and here. And in that way I know where to set my Z closure based on the top of the ribs. Same thing as before, we're going to use some double bead beetle tape. We can pre-apply that to the bottom. So after the starter one's a little different because you have the Z closure at the edge. After that, all the Z closure is going to be about the same. It's going to be a little wider because this one has a portion removed, but in normal situations they would not. So we can just pre-apply our beetle tape. Install that. Take that wax paper off, work it under, and just make sure we're to our marks. Metal's a little bit flexible, which makes it nice. And that's going to close off between the ribs. One thing that I don't have with me is tube sealant. So we put a bead of tube sealant on the sides. So that's one thing I can't really reflect here because I don't have the tube sealant. We'd seal the side off here and here. Just to seal the vertical edge of that Z closure. And then we're going to take pancakes, and usually just a few pancakes is fine. 2 or 3, depending on the width of the panel. 1 on each side and 1 in the middle is usually sufficient. And so what you can see is the beetle tape is acting as a gasket between the Z closure at the top and the panel. We're going to use sealant going on the crack right there where there's a gap, and on the other side where there's a gap. Those gaps are very nominal, but we will still want to go and seal those off. We'd go all the way down the roof that way. One thing of interest, if for whatever reason you wanted to vent your roof, assuming the pitch is not a half 12, because a half 12 is almost flat and you would not want to vent that. That's a commercial project usually. But assuming it's not, we offer Snap Z. So instead of sealing the top of your panel, it's vented, has a vent material on the back, and it has beetle tape pre-applied. So all of our standing seam systems, we can provide this for. Again, if it's a half 12 slope, this is not what you're looking for. You're going to seal the top of that off completely. But assuming you have a typical slope and you want to vent it, this is a great option to vent between the panel ribs at the ridge. You would use pancake screws In this case, all 5 of them. Probably we'll stick with all 5. And you would also use typically a little wider ridge cap. So instead of, say, a 12 or 13-inch ridge, I would highly recommend a 16-inch ridge with, instead of a half-inch hem that's open, you want to go with about a 3/4 or 1-inch open hem when you use the SnapZ system. Excellent system, just really, really great. So again, this is our mechanical seam 150. We talked about the extended eave at the bottom. We talked about the panel itself, cutting off the ribs, 1.5 inches on each side, folding the panel under with the hemming tool. We installed our first panel. We installed our clips. So in this case, we installed our floating clips, but you can also use a fixed clip depending on installation. We locked over our next panel. Because we're working from an edge, such as a ridge or an eave, we didn't have to pre-hand seam anything. We just started at the start mark, right at the edge of the panel, and worked our way up. And then we used the hand seamers just to finish off the last maybe 16 inches at the top. And then we would continue that way. If you have to start at the top and it's going to be at an end wall or a transition, you may have to field seam the top of the panel about 8.5 inches fully seamed and another 8.5 inches seamed at a 90 so that the tool has a place to start. The tool has to have a place to start that is already either somewhat off the roof to allow for that start position or pre-seamed to 190 up to that start position, and then, 90, and then 90 for the remainder of the tool. So it's set at the start position. So then we talked about the Z-closure. So we've got Z-closure that's fastened in place with pancake screws. But before we did that, we pre-applied our double bead butyl tape. It's just like caulk on a roll that doesn't dry out. So we pre-applied that to the back of the Z-closure. And then when we got ready to set it in place, we marked so that the rake open hem would lock onto that Z-closure. And we went ahead and pulled off the wax paper, set that in place, used the pancakes, locked over our rake trim. You can use an 1/8 inch bit, but in this case I used the Malco hole punch with the 1/8 inch bit. I was able to punch through all 3 layers of metal, set just a little bit under a 1/2 inch so that it could hit that hem. You don't have to hit the hem, but in this case I did. Then we talked about the Z-closure at the top. Instead of long links like you would a rake or a sidewall, the top of the panel is almost always going to have a Z-closure that's cut to fit. So this is a starter piece, but after that you'd have similar length panel pieces in between each panel. Butyl tape on the bottom, just like on the side, so that acts as a gasket between the trim and the panel. Pancake screws to hold that in place. And generally we would lock the top, or we lock the end wall or transition or whatever is at the top of the panel onto that Z-closure. We also talked about if you're venting, SnapZ is a great option. Highly recommend it. Cut to fit. So these are all pre-cut. Butyl tape already pre-applied on the bottom. Just a great all-around product. This is what I am venting my ridge with. So highly recommended. 10 out of 10. 10 out of 10. Real quick, the last thing I'm going to show you, and if this wasn't Galvalume, I'd probably use some cardboard on it. But you can also tighten those hems up just a little bit more if you like with the hand seamers. So it just tightens that hem up just a little bit more. I like the look of it. I don't know if it matters for endurance or anything like that, but it just makes the edge of that hem look really, really nice. So hand seamer is great for trim, great for straightening out a little bit of trim, great for bending trim. So we talked a little bit about that, and also great for tightening up hems for when you've hemmed a standing seam panel. Most of these concepts are the same for all of our standing seam. So the great news is you just don't have to use the seamer. The seamer is available for the 1.5 inch. The seamer is also, a different seamer is available for the 2 inch. So make sure you look at those. We sell those, and we also rent those out. So we offer that as a service as well. So just depend on what you're looking for. But other than that, just note that outside of the clips being a little different, and the fact that you need to seam it, all the rest of the concepts shown apply to all of our standing seam that Best Buy Metals manufactures. So the last thing I want to talk about is a scenario where you're working from end wall or transition. In that situation, if you're going from left to right, you're starting at the eave, everything's just as normal. You can go ahead and run your seamer up, no issue there. But if you're working from right to left, you're going to have to work the tool from top to bottom. And if you're working your tool from top to bottom at a ridge or a high side peak, there's no issue because the tool can be further than the edge, and you can just work down from there. You can have your start mark right at the edge of the panel. But if you have an end wall or transition, the best bet is try to have your panels going from left to right so you can work from the bottom up. If for whatever reason that's not reasonable or feasible, you can still work from the top down, but you need to work through a couple of different steps compared to normal. So I'm going to show that right now. Of note is I'm not going to use an extended eave. I'm not going to hem the panel. This is just to talk about hemming from the top down from an end wall or a transition where you don't have the clearance for the drill assist tool. So I'm just going to tack this panel in place. In normal situations, it would be hemmed, and/or all the screws would be going underneath of a trim. But for the sake of this demonstration, I'm just going to hold it in place. All right, just like before, we're going to put our clips in place. These are floating clips. Fixed clips will work the same way as far as installation. It's easier to grab one at a time. So once your first panel's in place, clips are fastened. Again, usually anywhere from 2 to 5 foot apart, depending on the specifications of your project. The wind resistance, and also if you're going over like 2-inch panel can go over open framing, steel framing up to 5 foot apart. So just depend on those scenarios. We're going to put the next panel in place. Again, just like before, I'm just going to tack this into place just to show the seaming, not so much for the rest of the deck. All right, so panels are in place. This is where things change. First thing I'm going to do is fold 2 lengths of the hand seamer FSHS. So I'm going to start at the very top, edge of the panel, right at that inside corner. That is going to go right at the inside corner of the portion that's not seamed. So we're going to start out that way. Anytime you're hand seaming, that's how it's going to start. I'm going to go ahead and fold that over to a 90. And I'm going to make a mark at that spot. This is going to be right where I put the start position on the power assist. And so what I'm going to do is I'm going to do one more at 90. Then I flip the tool over. I'm going to hem it to 180 from the start position. So right there at that start position, you kind of have to dig your tool in. So instead of going this way, I flipped it the opposite direction. I've got to dig it in at the bottom. And make that 180 bend. So we have start position, 180 all the way to the start position. And then we have 90, another length of the hand seamer. So 90 degrees to here, 180 degrees at the back of the tool. So getting the tool ready, a few things about the tool. So again, normally if we got to open it up. I'm actually going to go ahead and set this to the heavy position just so I can see my sight hole, my sight line right here. My start position is here. So that start position needs to line up with that line over there. That one, sure, the panel can start. Another thing we're going to do is when we get to the bottom, we're going to stop the tool with the wheels still on the panel. We are not going to continue past that. In fact, if you want to go ahead and just make a note, just go ahead and stop it with the roller on the panel. Just why go further than you need to? We're going to finish that last bit off with the hand seamers at the bottom as well, just to be safe. So again, what I'm going to do is I'm going to go ahead and line up that start just approximately at that start line. Everything's opened up. I'm aiming it up. There's a little bar in there that helps verify that. I'm going to go ahead and rotate that back to the correct gauge because I don't really need to see that anymore. I already have it set. I'm going to go ahead and engage my rollers. So rollers are engaged. The seaming material thickness is set to the correct thickness, and I'm at start. From here to here is seamed 90. From here to here is seamed 180. So that just ensures that we're ready to go. I'm going to use my remote trigger and roll it down until the front of the tool is at the edge of the panel or very close to that edge. One thing to note, because we're going downhill, depending on the pitch of the roof, you can have a tendency for the tool to rise on you one way or the other. We want to make sure that tool stays flush with the panel. If you have to hold your hand on that seamer to get that to happen, do that. But either way, make sure the seamer doesn't do this on you. So we're going to go ahead and work that down. And right when we get to the edge, we're going to stop right there and we're going to unengage the seamers. So we'll unengage the seamers, we'll remove the machine. And we're going to go ahead and work the rest of that panel with the hand seamers. So hand seamers, what we notice is right to here, it's already well bent, and then from here to here, it needs finished off, and from here to here, we need to work that to the 90. So I'm going to work a 90 into this last bit. So just like we did at the top to start, we've got the L shape at the top. Work that down. Make sure that's fully closed off. It won't hurt to go back up a little bit. We don't want to go past the point where it's not 90 anymore. And we're going to work it. We're going to dig the other, flip it around, dig the other end in, and just finish it off at a 180. So just finish the rest of that off. You can play around with the pressure depending on the gauge of the material, but that is going to be the best way to start and to stop a panel when you can't start it at the start position past the roof with the tool past the roof.